And today is a wonderful day for us. We have a lot of experienced professionals with us, uh, and we have today Mr. B.S.C. Rao, who is a structural engineer by himself and a forensic engineer. And we are very fortunate to have Professor Natarajan also here with us today. And we have Jolly Varghese sir and Anil Joseph sir. And I welcome everybody for this to this session. And I would welcome Dr. Anil Joseph to come forward and give a brief introduction about BSc Rao. Anil sir, please.
Good evening, all. Welcome, B.S.C. Rao sir and Natarajan Krishnamurthy sir. It's a great pleasure for us to have both of you in this forum today. And welcome Jolly Varghese, our chairman, to the program, and Nebu, our channel partner, and all my dear participants. It's a great pleasure for us to have such eminent personalities coming and sharing their vast knowledge with us. Before I start off the introduction, I would like to share with the August speakers and the August invited guests that today this program started in the midst of COVID pandemic. Once the construction site has all restarted and there were no laborers available, and most of the engineers were idling at site. So in Builders Association of India Executive Committee meeting, our chairman, Jolly, came up with the idea that why don't we engage them by improving their knowledge and make a platform where they can share their doubts as well as have a continuing engineering education. The unfortunate thing which is happening in our curriculum is that the moment we leave college, one disadvantage of our curriculum is that we don't have a practical training sessions as part of curriculum. And the second disadvantage is that moment we leave college, we have never made it a compulsory activity to have continuing education. So whatever is there, we learn at site, and if you are constrained to one area, your knowledge is limited to that area. That is why this idea was muted, and like in other developed nations where the continuing engineering education is a must, we thought Builders Association of India should open up to our employees where the companies will themselves provide the opportunity for them to have this platform. And more importantly, what we have seen here is that there is a lot of people who are in the field who have problem, and this is working as a peer platform for them to interact with each other. Because generally when they say they will be a bit reluctant, Natarajan sir and Rao sir, to ask question to seniors. But when they have a platform where they are interacting with each other right from Trivandrum to Calicut, so they find that it is easy for them to discuss the problem, and in between we keep bus session or interactive session where they will be able to ask us question. And now once it was started at 11 o'clock in the morning, where we were planning that they should plan the work accordingly and they should find that 1.5 hour time to spend for this session. Later on, we moved it to the evening because all the construction site has started and was busy. And from January onwards, we made it into 7:30 p.m. in the evening on every alternate Tuesdays. And this is just briefing of the program. And thank you, Chairman, for the initiation. And we have completed so far 19 sessions, including the interactive sessions. And this is the 16th technical session. And today we have with us eminent personality in the forensic engineering in the country, and also an international expert joining us today, and it will be a great big day for us. And let me have the privilege for introducing engineer B.S.C. Rao to this audience. B.S.C. Rao is a highly qualified consulting civil engineer living in Bangalore with over 47 years of experience in the planning, designing, construction and management of large engineering, industrial and infrastructure projects, especially in mass rapid transit system, in which he has over 36 years of experience. That's quite a long experience, and there is a lot of data to be shared there. He was formerly Executive Director of Bangalore Mass Rapid Transit Limited, precursor to the current BMRCL, and was responsible for planning and structuring the SY Elevated Light Rail Transit System project, on which the Namma Metro project now being executed is broadly based. He has been consultant and technical advisor for several companies and projects in transportation infrastructure and MRT systems, and was member of several government advisory committees. He was also a two-term chairman of the Bangalore Center of the Association of Consulting Civil Engineers India and was its national president in the period 2011 to 13. As chairman, he conceived and organized the series of biennial conferences on recent developments in design and construction technology. Redcon for ACCI Bangalore since 2005, which has gone through 8 editions till date. Congratulations, sir, for the excellent knowledge sharing platform which you have initiated. During his presidency of Association of Consulting Civil Engineers, he introduced forensic civil engineering in India as a subject through a national conference on FC in 2018 and international conference in 2016 organized by him. He is currently busy with the third international conference, which is to be which is proposed to be held in 2021. He has had an avid interest in forensic civil engineering and has done much to popularize the subject in the country for many years. In fact, the forensic civil engineering is something an essential, and we say that the experience failures are the stepping stone for experience, and you learn the most from the failures. And today we have a person, a national level personality who is going to present to us regarding the introduction to forensic civil engineering. And also we are very thankful to Natarajan sir joining so late for attending this program. Thank you very much, sir, for being with us. And now over to you, BSc Rao sir, for the session on introduction to forensic civil engineering.
Thank you, Mr. Joseph, and thank you, Nebu Abraham, both of you for first of all inviting me to give this talk under the auspices of the Builders Association of India. I'm really truly grateful to both of you. Thank you very much, because this is one opportunity of getting in contact with a large number of people in different parts of India, and I'm particularly honored that Professor Natarajan Krishnamurthy is with us. He is a very senior man and a very much more experienced person who is joining us from Singapore. So welcome, sir, and thank you very much for joining us. Okay, actually, forensic civil engineering is a subject that has been of great interest to me for many, many years. Ever since I started my career way back in 1973, and I came in contact, or rather I was exposed to failure very close to home when one of the structures that I was actually reviewing failed after it was constructed. It was a big, what you call, cooling tower basin, which was, when it was loaded with water, it suddenly collapsed, or not collapsed, it cracked right through. And the cracks were all typical bending cracks, and it opened my eyes to what can happen if your design is not proper. And it's a very old story. It's more than 45 years old, but it opened my eyes to what can happen if your design is not good and material properties they are exceeded, and the structure just fails. So that started my interest in forensic civil engineering, and also the fact that just a few years before, there was the Tarbela Dam collapse, or rather Tarbela Dam failure, very serious failure in Pakistan, which again occurred for totally mysterious reasons, and that accident happened twice, one after the other, and which was also a very interesting accident that took place. And subsequently, the Westgate Bridge disaster in Australia. All of these things were about at the same time, and which really got me very, very deeply interested in failures as such. And I've been an avid student of study of failures from 1973 onwards. So when I became president, I thought we should introduce this subject in India, because very, very few people really knew anything about failure investigation and so on. So I'll now start my presentation with this. Okay, where is the share screen? Yes, here it is. Okay, has it come?
Yes, sir.
Okay, here we are. Okay, has it come full screen?
Yes.
Okay, is my voice okay?
Perfect.
Okay, thank you.
Right.
So good evening, everybody, and welcome. I hope you'll be able to get some idea of forensic civil engineering, which is a very, very vast and complex subject. So I'll first start with a very simple notice about copyright, because This particular presentation has taken me more than 3 months to prepare. And of course, all of the data is from public sources or open domain sources, but nevertheless, the arrangement is mine. So I'm a little possessive about it. And then I'll also give a disclaimer, which is that I am not a forensic civil engineer, but I am a civil engineer deeply interested in forensic engineering, as I just mentioned to you. And there are very many eminent and very experienced domain experts who can speak with much greater depth and detail, like Professor Krishnamurthy, who is with us this evening. The scope of the subject of forensic civil engineering is very vast, so my talk will be essentially an overview of some important aspects of FCE and introduction of several concepts. Owing to the paucity of time, I presume I can take about an hour and a quarter. Nebu?
Yes,
Yes,
sir.
1 hour
Yes, sir.
15 minutes you can take it.
Thank you. I have got about 104 slides. I'll try to rush through them.
No, take it your space, sir. We are all ears to you. We want to
Okay.
hear it. It's an opportunity for us to learn a very interesting subject.
Thank you. So anyway, I actually removed quite a lot of the more theoretical aspects of investigation, and because this is a general audience, and I didn't want to trouble them too much about the theoretical aspects, but I have just touched upon some of them. Okay, I do hope at the end of this talk you would have got a better idea of what FCE is and what its scope is and how complex it can be. Okay, this will be the structure of my presentation, starting with definition of forensic civil engineering, building failures in India, definition of failure, causes of failure, the process of FCE investigation. Now, there are two parts to this. One is the forensic civil engineer as an investigator, and part two will be the forensic civil engineer as an expert witness in a court of law. We'll see that. And then we'll talk about very briefly about the utility of forensic civil engineering, and we'll talk about very briefly again about forensic archaeology. And this is a question that I've added. I mean, these last second 10 and 11 I've added for this program, which is because of several questions that have been raised when I've given this talk earlier. Where people are curious to know, how do I become a forensic civil engineer and what are the job prospects for me? Because while this is a fascinating subject, people get interested and they want to know what the future holds. And lastly, a few concluding remarks. So we'll start with the definition of forensic civil engineering. In Roman times, criminal charge meant presenting the case before a group of public individuals in the forum. So both the person accused and the accuser would give speeches based on their sides of the story. They had to defend themselves. And the individual with the best argument and delivery would determine the outcome of the case, who was able to better present his particular case. So this is what this is imagination of what it might have been. So here you have the two opposing parties arguing before a group of people, peers, and then ultimately the group would decide who had given the better presentation, and he would be the winner. So the word forensics comes from there. So the other picture of the same thing. The word forensic comes from the Latin word forensis, which means of or before the forum. The forum being the group of people that you just saw. This origin is the source of two modern usages of the word forensic, which is a form of legal evidence and a category of public presentation. So it's both the legal aspects of it as well as how you present it to the public. Medical doctors consider health to be the norm and disease the exception, and they become doctors by studying diseases. So they gain most of their knowledge from illnesses. If there were no diseases, you wouldn't have doctors. So illness is what drives people to know how the human body reacts and how to repair and how to heal people. Similarly, engineers also consider standing structures the norm and structural failures the exception. And much can be learned from the study of failures. Now, there's a very interesting definition of structural engineering, and it is the art of modeling materials we do not wholly understand into shapes we cannot precisely analyze to withstand forces we cannot properly assess in such a way that the public has no reason to suspect the extent of our ignorance. So civil engineering is a very, very approximate science. It's a very approximate science, and in the old days when I was a student, for example, we only had slide rules to work with, which only gave you maybe at most two places of decimals in whatever calculations you did. And it was a slide rule was a very simple calculating device that we had, and we certainly didn't have the sixth place of decimals in any answer. And therefore, that is how we have learned. In fact, when I was a student, we had a subject called approximate methods of structural analysis, where you could very, very quickly analyze a structure without getting into too many calculations and too many analysis. Now, unfortunately, those wonderful methods of analysis are now gone, but they are and were very useful. There is a great deal that we have learned from about materials, structures, and structural behavior, but there is very much more yet to learn. And in spite of all that we do, in spite of all the codes and all the accuracy and all this software that we now have, failures still continue to occur. When failures occur, there are consequences: physical damage to property and or injury or loss of life, financial costs for failure investigation, loss of time and production, repair and restoration, compensation for injury and death, legal fees. Every failure of some kind has some kind of financial implication as a consequence. And then, of course, there's also the legal liability and culpability if somebody has to pay for all this, and somebody is the cause for all this. Forensic civil engineering. How can I get rid of this? Okay. Forensic civil engineering may be explained as the application of the art and science of engineering to the investigation of materials, products, structures, or components that fail or do not operate or function as intended, or cause personal injury or damage to property. That is, the investigation of the physical causes of failures and accidents. The second part of it, which I mentioned earlier, is the legal aspect of it. Forensic engineering may also include the investigation of other sources of claims and litigations, preparation of engineering reports, testimony at hearings and trials, in administrative or judicial proceedings, and the rendition of advisory opinions to assist in the resolution of disputes affecting life and property. So whenever there's a failure, there's of course the physical cause of the failure, and then there's also the legal liability that ensues more often than not. So the engineer in the second case is called in as an expert witness. He has to give his expert opinion to the court of whatever is being presented and whatever is being argued. We'll see both of them a little later. In India, we have been having a continuing litany of building and structural failures with very, very depressing regularity. All over the world and in India, walls, buildings, bridges, dams, structures have been falling down with depressing regularity, with great loss of property, and very often with loss of many lives. In India, recently, India has witnessed a very large number of building and bridge collapses, especially bridge collapses. Bangalore had nearly 6 or 7 collapses of buildings under construction in just 2 months in 2013, when I organized the first forensic conference in Bangalore. In fact, one of the reasons why that conference got a tremendous amount of attention and participation from the public was because there were 2 buildings that collapsed within a week of each other, very close to the venue, which is Nimes Convention Center in Bangalore. Now you see here, these headlines have become so common that we now just look at them and move on. So these are all familiar headlines that you see, and unfortunately, what happens is where these accidents and failures occur, and there's a lot of publicity given for a short time, and then it fades from public memory. And the people who are so-called suspended are quietly brought in back, and things continue as before. Now, bridge collapses have been a very interesting thing that have been happening with tremendous frequency, and this is just a representative sample of some of them. And here you find I made a list of bridge collapses that have occurred over the last 8 years or 9 years now. And this is just again a sample. So these are all things that are happening over and over and over again. So what is it that we understand from this? That failures occur and they continue to occur, and nothing is really happening to change this unfortunate series of occurrences that's happening. Okay, between 2001 and 15, 7 people died per day in collapse of structures and buildings. Data from the National Crime Record Bureau indicates that 38,363 people lost their lives between in 15 years between 2001 and 15, and most people lost their lives on collapse because of the collapse of residential houses. Unfortunately, for some reason, from 2015 onwards, the NCRB has stopped publishing these statistics. I wish they had continued. Now, this is just a representative sample of a graphical representation of total collapse of structures and deaths by the number of structures. You see, for example, here, this 30,298 in just buildings alone between 2001 and 15. Okay, this again just to show you that it's a very almost flat graph that you see here. So that means nothing much is changing and people are continuing to die year after year. Now we come to definition of failure. Structures and buildings fail all the time. But what do you mean by fail? Jack Devney, Jack Janney defined 3 types of failure. One is structural distress, which is an impairment of the strength or load response of a structure, which may limit its use as intended. This is one. The second one is structural failure, which is the reduction of the capability of a structural system or component to such a degree that it cannot safely serve its intended purpose. And the third one, of course, is structural collapse, which is gross movement of major members or a significant portion of the structural system manifested by the creation of rubble from breakage of members themselves or elements supported by them. Now, just to show you pictures of how all of these are failures, if the paint flakes off or if there's leakage or there's tile, this issue of tiles, you will see in many new buildings which are coming up where the entire floor rises up and the tiles break up. And this again, you have seen corrosion of reinforcement. These are all failures and they all have a reason or many reasons. Again, these are all cracks that you see in plaster, you see cracks in walls. And then you have structural weakness where, for example, in this case, this thing has settled and the whole porch has actually collapsed, or not collapsed, it has sunk. Here you have differential sinking, and therefore you have differential settlement, therefore you have cracking of walls. Sometimes the building can collapse because of that. Then we have the famous Leaning Tower of Pisa, and then we have got a number of leaning towers of buildings in many cities. This happened very recently in Bangalore, and the building had to be demolished. And then if you don't give proper foundations and you've got a weak soil, then this is what happens. A brand new building just sinks to one side. Now, this is another interesting failure. The John Hancock Tower in Boston was known for a period after construction as a plywood palace because of a design flaw in the windows, which meant that they had to be replaced temporarily. All the glass sheets fell down, and they had to be replaced with plywood. So that is a failure. Again, why it has happened, you need to investigate. Then the Ladner Leisure Center in Vancouver, Canada was evacuated after a large part of the facade fell down. Now, Sydney Opera House, you wouldn't think is a failure, but it has been a massive failure of project management, and that is also a failure. The cost overrun, it was supposed to cost $7 million when it was designed in 1963, but because of the various flaws that were discovered in the building, the cost went up to $102 million, and the construction continued for 10 years from 1963 to 73. And for about 20 years thereafter, there are a series of numerous technical, acoustic, and mechanical problems that plagued the structure for many years thereafter. Now, of course, all of that has been set right, and we really don't know how much it will ultimately cost. But the cost overrun and the time that has taken is an indication of failure of project management. Then we can have partial collapse, where one side of the building collapses. We have seen a number of these cases that have happened in recent times. In Bangalore itself, we have seen a few of those. And then, of course, ultimately, it is total collapse where the entire structure fails. The one on the right is the Kobe earthquake that happened, and then here you see one building which has fallen down during an earthquake. The reasons are many, but the structure has failed. Now here you see the dam that has failed. Okay, now we come to the causes of failure. The causes of failure are many. First and foremost and most important is human error. Ignorance, inexperience, incompetence, carelessness, mismanagement rather, miscommunication, bad coordination, negligence, and not least, greed and corruption, which really dominate in quite a lot of these cases. Initial assessment of requirements have not been properly assessed, or they have been inadequate or absent. That can cause later problems because the structure is unable to take the loads that actually come on them because of a bad assessment of requirements in the beginning. Design and drafting, an area which requires a lot of attention. And in fact, when I was working in Tata Consulting Engineers, this was something that was very, very, very intently emphasized, very strongly emphasized, to ensure that we had a proper quality assurance system, to ensure that the designs were properly made, and then that the designs were properly transferred to the drawings, and peer review becomes a very major issue. Subsequently, when I joined an American company, the systems that I had learned in Tata Consulting Engineers were far greater advanced, and we required to have 5 signatures from 5 different people before any drawing or design could be termed as accepted. Finally, by the quality assurance manager who oversaw the whole business. So quality assurance is a very big issue, and peer review is a very important requirement to ensure the design and drafting are properly done. Construction, of course, there are so many things that can go wrong. Bad practice, no supervision, again, no quality assurance or quality control. So these are and of course, bad practice is when you're careless. Then materials are substandard or insufficient. A lot of people cut material costs in order to cut costs, and therefore the structure becomes weak. In practice, you have overloading, misuse, alteration, lack of safety. In fact, one of the many things that have now been introduced is that when you have when you design, especially industrial floors and so on, you are required to put a plaque or a notice on the floor to say what is the maximum permissible load that it's capable of taking. And that becomes very important in areas like factories, warehouses, and so on. So the quite often overloading. In fact, there's a case I read about some 50 years ago, where there was an 8-story building that failed in a sequential collapse because the top floor was overloaded with newsprint paper, much more than the floor was designed, and the whole building came down. Then maintenance is improper, inadequate, absent. Of course, for all of these, you will have a large number of actual cases that one can learn from. Then force majeure. Of course, you have earthquakes, you have terrorism, you have natural events, all kinds of things. That is another cause for failure. And accidents, you have blasts, explosions, and so on. And lastly, age, deterioration. And if you don't take proper care, then a structure naturally deteriorates, and that can cause failure. But out of all this, what is interesting is that human error dominates the whole lot, and 92% of all failures are attributable to human error. Accidents and failures occur. That is an inescapable fact of life. There is always a cause or many causes for every failure. Edward Locard, a pioneer of forensic engineering, had made a very famous statement called "every contact leaves a trace." That means for everything that happens, you have a way of finding out what happened. It leaves a trace. Now, a failure has an immediate or proximate cause, the first cause because of which it failed. But behind that, there may be many underlying causes that led to the final failure. The immediate proximate cause can be said to be the last piece of load that broke the camel's back. So that is the approximate cause, but many underlying causes are maybe the camel was weak and you had not taken care of that. So there are many other underlying causes. But then ultimately, the forensic engineer needs to find out what are the root causes, that is the fundamental causes that cause the failure. The job of the forensic engineer is to find the root causes and understand how and why the failure occurred. We'll quickly go through the forensic civil engineering investigation process. We have a building that collapses. There's a building in China that just toppled over. In fact, if you go to the internet and you search for this picture, you got some very, very interesting analysis of what actually happened when this building just literally toppled over, slept over. Okay, the forensic civil engineer is brought in to investigate the failure after it has occurred, and he has now got to work backwards from what he sees in front of, I mean, what you see in front of you, to find out what actually happened. So from the aftermath, he has to go back, work backwards to finding all the reasons why the failure occurred and to find the root causes. In this endeavor, the forensic engineer has two roles to play, which I mentioned earlier. One is as an investigator, and second thing as an expert witness or an advisor to a court of law. We see part one as the investigator. Ideally, the investigation comprises, will or should comprise of many sequential steps. First, the appointment of the forensic engineer. He must be competent, he must be knowledgeable and an experienced person so that he is able to conduct a proper investigation. And then you have, once he is appointed, his brief also must be very carefully worded and structured so that what you need to get, you get at the end of it. So there's a pre-investigation preliminary assessment, and an important part of this is that the site of the failure should not be disturbed. Unfortunately, what happens is when a building fails or a building collapses, for example, hundreds of people rush in order to, of course, with the natural anxiety of saving people, but in the process, what happens is the entire site is disturbed, and it becomes very, very difficult for the forensic engineer to find out what actually happened and what were the causes that led to the failure. So detailed planning and of the sequence of investigative procedure is carried out by the forensic investigator. He determines what tests need to be done based on what he finds. And he also has to find out what information do we have or what information can we get. Now here it is not just one person. This requires the collective action or collective participation of a number of people. And in this case, too many cooks spoil the broth does not apply. In fact, the more the merrier, the larger the number of heads, the better you get ideas of further investigation or investigation routes. So then the investigator will have to describe, characterize, and define the failure. What kind of failure is it? So you will have to first make an assumption or rather a theory of what might have happened, and you have to define the failure. And you collect as much site evidence as possible, physical, material, photo, video, oral, through interviews, very, very important. Documentary, collect as many documents as you can, and pay attention to everyone and everything. A cardinal rule here is that no detail is too small. Every detail is important. The forensic engineer must personally visit the site. He can't sit in the office and direct others to do it and then look at what they have brought. If he is the forensic investigator, he has to be on site and he has to direct the forensic investigation process. He has to collect as much evidence. He has to ask the six WH questions. That is what, why, when, where, which, how, and lastly who. All these questions are important, and you get answers for every one of them. And the investigator has to make sure that all these questions are really answered, and he gets proof, documentary, visual, whatever. And this is the most important activity. And without sufficient, detailed, and exhaustive evidence, the investigation would be futile, as nothing can be proved. Ultimately, you must remember that this may go to a court of law, and in the court of law, the court is very, very meticulous as to the nature of proof or the standard of proof that is given. So evidence has to be solid. It should not be capable of being refuted or challenged. So collecting information and substantive information is extremely important. He has to analyze the evidence that he has got, which itself would involve several activities, including material testing, hypothesize the possible sequence of events that led to and determine the root causes for the failure. So he has to first make a theory as to what might have happened, and then he has to create a failure model and failure hypothesis. Excuse me, please. Create a failure model and failure hypothesis. And then he has to validate that hypothesis through structural analysis, model testing, research, literary review, etc. So not only do you create a model, but then you also have to show that your model is valid. Now there are many methods, you will see that later on, about how you validate the hypothesis. And then having done that, you arrive at a reasonable conclusion regarding the root causes of the failure that resulted in the failure. You must be able to prove this was the only reasonable way it could have happened. And for that, you must have solid evidence. Then you determine what is the further course of action. What now needs to be done? Is it repair, restoration, rehabilitation, retrofitting, or at the last resort, demolition? So, depending on the nature of the failure and depending upon the amount of damage that has been caused, one of these various, they are all different, incidentally. One of these courses of action will have to be taken up. And then finally, you prepare an exhaustive report fully describing the process adopted with supporting documentation and conclusion reached with sufficient justification. And finally, make an estimate of the monetary loss if required. This becomes important in determining the compensation payable and the reparation for loss, especially in a court of law. And provide expert testimony in a court of law as an expert witness if called upon to do so. The forensic engineer must provide only the facts, never his opinions about who is responsible. That is for the court to decide. He is only the person who collects evidence and presents the evidence and nothing more. He doesn't draw conclusions. He only says what might have happened, what might be the physical reasons why a failure has occurred, but it is not his job to say who is responsible for the failure. So that is for the court to decide. So the work of the forensic engineer ends with collecting physical evidence and presenting physical evidence, and that is the end of the story. The rules. First of all, you should not assume anything. Assumption is the death of a good investigation. The moment you assume, then the conclusion is fixed. You must have an open mind. You must be capable of considering all possibilities. You cannot say this is how it must have happened, and then the rest of the investigation is then predicated upon what you have assumed. So don't assume anything. Believe no one. Everyone has something to hide. They all know that. The forensic engineer must make his own independent assessments. He has to get information. He has to talk to people, interview people, and then make his own assessment on what the validity or otherwise of what people tell him. Check everything. The attention to detail is crucial. The smallest clue might be the biggest breakthrough. The devil is in the detail. The greater the detail, the better the understanding. Nothing is impossible. Read rule number 1. That is, assume nothing. Anything is possible. If all other causes have been thoroughly investigated and discarded, then the impossible is probably the most likely explanation, even if it goes against all logic. That means ultimately that has to be the only explanation that says why a particular thing occurred. The reliability of forensic investigations depends on several factors. Some troubling questions arise. This has become a major issue in forensic civil engineering investigations because the question is ultimately it is a human being who is carrying out these investigations, and the question arises: how reliable is what he has presented? Now here, after failure, a huge amount of information will be collected. How do you determine what is important and what is not? Now, what happens is sometimes in quite a lot of these cases, depending upon who you're working for and what kind of pressures are being you are being put under, sometimes you make selective choices of what is important and what is not. Which of them will lead to finding the causes? The next question is, who appoints a forensic engineer? What is his brief? As I said earlier, his brief must be very clear and very comprehensive so that you get the answers that you're looking for. Will or should the forensic investigator look beyond his brief? So if he is asked to do a certain set of investigations, should he, in his professional capacity and being professionally independent, look beyond what he has been asked to do, or be do only what he is asked to do considering the fees he is paid? These are ethical questions that come into the picture, and it becomes very important to have, if you want to have an impartial investigation into the whole thing, to ensure that the forensic investigator has a free hand. But in real life, it doesn't work like that. In fact, what you have heard till now in the earlier slides is the ideal condition. But life is not ideal. Life is full of realities. And these are what you see in real life, where you are brought under pressure, you are brought under what you call threats, for example, or you are induced, monetary inducements are used, and so on. So the integrity of the forensic investigator becomes a matter of great importance. So, should he limit his investigation only to the extent of protecting his client's interest? What if the facts are inimical or contrary to the client's interest? So, there's an ethical question that comes here. Should he act professionally as an independent investigator, or should he be bound by what his client tells him and how much he is paid? These are very, very serious, what you call ethical questions that come up in forensic investigations, and they are very what you call very troubling. What does he do if the facts do not match what appears to be the most likely scenario? How is he going to handle that? If he is investigating something and he is trying to develop a theory, and what the facts are don't match his theory, then what does he do? How to ensure impartiality and the quality of investigation and the reliability of result? Now, this particular slide which I have put in here is to show you the moral dilemma and the ethical dilemma that the forensic investigator faces in conducting any investigation that he is asked to do. Now, this shows you the overall flow chart of how forensic investigation takes place. First of all is the appointment of the forensic investigator. Then you have the failure. So appointment of the attorney and the forensic investigator. Then you plan the investigation. Then you have investigation, collect evidence, and you do the lab research, lab testing, analysis, and conclusions, and final report, which I have described at some length earlier. And finally, if it goes to court, you take part in the legal proceedings as an expert witness or as an invited witness. Now, again, these are all ideal conditions. A good forensic investigator should have superior technical competence and thorough knowledge of his subject, an excellent understanding of structural and material behavior. Remember, he is being brought in as an expert on the subject, and unless he is thorough in his subject, he will not be able to carry out a proper investigation. So he must be of a very eminent standing. He must be of of tremendous knowledge in his subject. He must be an expert in what he is doing. If the case go to court, remember the defense will have equally competent engineers and very cunning lawyers who will question your every statement and try to trip you using your own arguments. In fact, quite a lot of cases have been lost because the defending engineer was unable to answer the question, and lawyers are very clever in using your own arguments to trip you. So you must also have your presence of mind, and you must be able to ensure that what you're saying is factual, and that you cannot, and you one of the important things is you must be very clear. You cannot give vague statements. The moment you give vague statements, then you get into trouble, real serious trouble. In fact, Dr. Krishnamurthy will be able to give many examples of how engineers have failed as expert witnesses in a court of law. A good level of general knowledge of related and sometimes even unrelated disciplines. While you are an expert in your own subject, a good knowledge of other subjects also greatly helps, because then it will enlarge your ability to conduct the investigation and bring in additional experts if required to substantiate what you are finding. I'm sorry, something is happening here. Okay. And then he must be able to use effectively various tools and techniques, especially graphics, videos, charts, animations, models, simulations, etc. That means, in addition to being technically competent, you must also be, how shall I put it, a media person, in able to be able to explain what you're talking about to a what you might call lay audience, a person, people who are not of the same level of knowledge as you have. Most often than not, you will find that people don't know what you're talking about, and it becomes very, very important to translate complex subjects into much simpler language and make it visual so that people understand what you're talking about. He must be fluent. He must be able to speak fluently, confident, and articulate with good communication skills. He must be able to present what he's talking about so that the other person understands and also is convinced about what he's saying as being correct. It is especially important for the forensic engineer to explain effectively complex technical matters in simple day to day language. And this is a skill that one acquires. And in fact, there is a very, very interesting website called, I think it's called the Litigation Consultant. And if you go to the website, you will find dozens and dozens of, in fact, large number of manuals, large number of court cases where they teach you how to actually present forensic evidence in a court or to the public, and it is very, very interesting. It's something that you should try to visit if you can. Patience and perseverance, very, very important. You should never lose your nerve, and they'll put you under tremendous pressure to counteract what you're saying. And you must have your patience, you must have your perseverance, and you must be have a very clear head at all times. And very important, you must have plain common sense and intuition. Intuition, of course, is inborn. Plain common sense is the most uncommon of senses. But if you have both of these in good measure, you are a blessed person. And lastly, honesty, impartiality, and ethical integrity. He should not take sides. And temptation is a very, very big problem, as you have just seen in the previous slide, where I talked about the ethical problems of being a forensic investigator. Now, all of these, as you see, are the ideal conditions, but life is not ideal. Tools and techniques for the forensic investigator. There are empirical methods. Empirical methods essentially cover physical testing of materials, either in the field or in the laboratory. And of course, quite all of you who are practicing civil engineers know most of these empirical methods of physical testings of materials. I will not go into that. I mean, for example, that's a very, very big subject by itself, and I will not get into that. Then we have destructive tests, lab tests, and you have semi-destructive tests, such as, for example, we have all these and many others. In fact, again, a concrete lab technician would be able to give you a lot more information. There are literally dozens of tests that you can do which are semi-destructive. And you have non-destructive tests. NDT is again a huge field. It's a massive field. And there are people who have concrete laboratories who have got literally dozens of tests that can be done. Quite in addition to which, you have things like optical scanning, electron microscopy, X-ray diffraction, physical and chemical analysis, X-ray and gamma ray radiography, liquid penetration testing. Depending on the material, there are literally dozens of tests that can be used to carry out NDT, non-destructive tests on materials. And then we come to the theoretical methods. I've skipped that whole business of testing because that's a massive subject, massive field, and you can have probably 8 hours of discussions on just those subjects alone. Again, this is another area which is very big. Many modern, well-established and formal analytical tools, techniques, and procedures are available, which are commonly used to carry out forensic engineering and major accident investigations, which occur due to several and often interrelated causes. These methods can be used for different kinds of investigation. Complex accidents and failures may require use of more than one technique to get a complete picture of the nature, number, sequence, severity of underlying causes. So it's a very complex set of exercises that the forensic investigator has to do before he can come up with the causes for what happened. Now, we have basically two types of analysis. One is called the deductive analysis, or the bottom-up approach, or the top-down approach. And then we have the inductive analysis, which is the bottom-up approach. And of course, we have computer analysis and model building. We'll quickly go through some of these with a little more emphasis on And then after all the analysis is done, you create a hypothesis and you validate the hypothesis, as we have seen earlier. And out of these, we will basically talk about deductive inductive analysis very briefly, and also model building. Okay, now this is a very famous diagram called the bow tie diagram. And what you have here is, this is the event. What you see in the middle, this is the event, the failure, for example. And we have what is known as the fault tree systems, which go to the left. That means from the event, you work backwards to find the root causes, as you see on the left side. Now that is the deductive or top-down event, top-down system, the top-down method that we use. Then we have another system called the inductive method, which is the bottom-up approach, which is where you have very number of causes, you have a number of consequences, and you take each of the causes and you work forwards, finding out for each cause what are the effects that you get. So, say for example, if you have a break in a particular component, what will that break lead to in terms of the operation of the system in which it is implanted? So you work backwards or you work forwards from a given cause to all the possible consequences that it might have. So this is known as the inductive approach or the bottom-up approach. We'll quickly go through both of them. Deductive analysis, the top-down method, is also known as causal analysis. As we said earlier, every consequence has a cause. From the consequence, you come to the cause. That's what the approach is. Every cause must have both necessary and sufficient conditions. Every cause must be both necessary as well as sufficient. Now we are getting a little into theory, so I'm going to skip a little bit of the theory part of it. So a necessary condition is one in which the event cannot occur. That means if that particular cause is not present, then the failure could not occur. And a sufficient condition is one in which if the cause is there, then the failure must occur. So an example of this would be, for example, if you have a building which is designed just enough for dead load and live load, to take a very simplified example, but you have not designed it for earthquake, then if you don't have the earthquake, then the building will not fail because it is designed for dead load and live load, and of course things like wind load and so on, for example. But suppose an earthquake does occur, then the building has to fail because it is not designed for earthquake. So in which case earthquake becomes the necessary and sufficient condition for the failure of the building during an earthquake. That is what this means. So a necessary condition and a sufficient condition, both are necessary for a cause to be identified as a cause. Now this gives to something called causal analysis, and there are many types of causes. The fault tree analysis is a big subject by itself. Events and causal factors charting, ECFC, is also a big subject. We will only take the simplest of them, root cause analysis. Again, there are a number of different types of root cause analysis that can be done, but I have taken a very, very simple example to give you a flavor of how such an analysis is done. Say, for example, a building has fallen. That is a failure. That is the event. Now, the immediate cause, you remember we talked about the proximate cause. The immediate cause is the foundation failed. The foundation sank or the foundation failed. It cracked, whatever it is, the building has fallen. Why did the foundation fail? That is the next question. So this is called the why because analysis. So the immediate cause is the foundation failure. Why did the foundation fail? Is it because of a design error? Or if it is a design error, then you again ask the question, why did the design error occur? There can be many reasons why the design error occurred. So again, you find the causes, out of which you will find one cause which is predominant. The other causes are not important. So that becomes the root cause for this particular event, design error. Say, for example, the person made a mistake in the decimal calculation. Then the question comes, why did he make a mistake in the decimal calculation? And you go on asking the same question and you start looking at it. Maybe he was tired on that day, whatever it is. So for every cause, there are a number of root causes. One of them or two of them or three of them are maybe important. The others may not be. So this is one cause, design error. Then you have construction error. You can ask, why did a construction error occur? Perhaps they they designed it, they built it improperly, they didn't put enough reinforcement, maybe they have not enough laps, whatever it is. So again, you have a number of root causes for construction error. One or more of them may be reasons for that construction error to have occurred. Then you may have other causes. Many other causes might have come up, which you have to identify. Now, for example, other causes might be that the building was all right, the foundation was all right, everything was all right, but the next door neighbor started building a huge basement excavation, and because of that, and he didn't provide, let us say, adequate shoring support or lateral support for the sides of the excavation, and the excavation collapsed. Of course, once the excavation collapses, the building falls. It has nothing to do with design or construction, but it is some other extraneous cause which has caused the failure. Now you can say why. Now the next question is, why did the excavation collapse? So again, you look for that. It can be inadequate lateral support, and that, why did they provide inadequate lateral support? Again, there may be a number of causes for that. Then we can also have heavy rain, root cause. Now you can say, now heavy rain, why did heavy rain occur? It is a natural occurrence, so therefore there is nothing further to ask on this question. It becomes one of the root causes. Now, similarly, other causes can have many other subsidiary causes, and again, they can have their sub causes and so on. So you continue like this until you come to a series of root causes which you cannot further break down, and that set of causes which you cannot further break down become the root causes ultimately for what the failure occurred. So these, after the immediate or proximate cause, these are all the subordinate causes. I'm sorry, this is a mistake. The immediate cause, and then the supporting causes which come at the bottom. So this is what you call a causal failure root tree analysis that you do, and then you have the root causes at the end of it. Now here is a very interesting case of a ship which is a ferry in Belgium. Now this ferry was always used to transport people from Belgium to Norway, and in March 1987, it was berthed at Zeebrugge port, and this is one of those ships that you call the roll-on, roll-off system, where the front system or the front panel of the ship falls down, and vehicles inside the ship can then directly roll off the ship into the port. Now, what happened was, in this particular case, here you can see the open front port. What happened was, the platform had been lowered, and the unloading of all the vehicles inside the ship had been completed, and all the loading of the new vehicles inside the ship also had been completed. And the order was, and then the message came to the captain that all the procedures have been completed, and the harbor master confirmed that by tooting on the harbor signal to say loading is completed, unloading is completed, you are now free to leave. Now the problem was, the ship left immediately while the front platform was still in the lowered position. What happened was that the person who is in charge, the sailor in charge of informing the captain that the platform had been raised, he was not aware that the captain did not know about it. Because the harbor master gave it, the captain started the ship, and this sailor who was there, did not communicate to the captain that the platform had to be raised, and it had not been raised. So the net result was that the front part of the ship was totally open to water, and it is lower than the water level. So as a result, in less than 5 minutes, water entered the hold, and the ship just turned over and sank into the water as you can see, quite close to the port, and 193 people died. And of course, this subsequently led to a tremendous revision in the port procedures and the ship procedures, and they brought in instant communication systems between all parties on a ship so that such a problem never occurred. Now, this is the partial failure investigation root tree analysis that was done for this thing, and this is just a part of it. Just to show you an example of what I pointed out earlier about how complex it can get. And the more complex it gets, the more number of branches that you get down. And it can take quite a long time before the root causes are analyzed. Now we have seen the root cause analysis. We'll quickly see what is the inductive or bottom-up analysis. Here we have a cause and we find all the possible consequences that that cause can produce. So an inductive analysis is made to predict what consequences might occur for any given cause. This becomes particularly important in the case of machinery and in the case of systems. For example, if you've got a rocket, a spacecraft that has to go up, then you have to ensure that every possible misoccurrence or every possible failure in any component does not lead to a failure of the whole system. So, in fact, this question of inductive analysis and all the several methods of analysis, both root tree as well as this, actually started from the US space program, and they owe their origin to the space investigations that were done. So this is to ensure safe practices and ensure that all possible consequences of any initiating event can be foreseen and provided for, to ensure that the failure of one particular thing does not lead to a calamitous failure of the whole system of what you call equipment. So this is to produce fail-safe systems and to imagine every possible failure that might occur in a particular given system. And it is used in safety, reliability, and resilience engineering. This is as important as the root cause analysis, but in a forward way. So this is to ensure that structures don't fail, and this also becomes important in structural systems too, to ensure that you don't make mistakes in your structural analysis, and you try to create a structure that will stand even if some failure does occur. So resilient engineering is now a major field in engineering. So this is designed for resilient structures and systems. So inductive methods, there are literally dozens of inductive methods, and if you do inductive analysis, if you type this search in the search engine, you will get literally dozens of them, and they're all very theoretical and some of them very complex. And as I told you, all of these, or almost all of them, have come as a consequence of the US space program. I think we have to thank them for inventing or developing all these various methods which are now available. And of course, they are highly automated, and they are very computer based, all of these, because no individual can do the kind of analysis and sub-analysis that is required in a short time. Then we have computer analysis. Of course, all of you are very familiar with computer systems. I'm not, again, this is another huge subject. There are so many different types of computer analysis that are available, and literally hundreds of programs are available. So I'm going to skip that, apart from just mentioning some of the names. Then we come finally to model building, where physical models are built. This becomes especially important in the case of presenting court evidence, and it also helps you to understand how a particular failure has occurred by actually simulating that failure in a physical model. And then it also helps in validation of hypotheses, and very helpful in code demonstrations. And one important part of this is it can be tested to destruction if it is required. Theoretical models, on the other hand, are very heavily dependent on computer methods. Computer graphics and animation are extremely useful in clarifying complex details, and especially in order to convey ideas to the public. Now, creation of hypothesis after a detailed investigation with available facts, investigator constructs a reasonable hypothesis about the likely sequence of events that led to the failure. So he creates a model, he creates a failure model of what happened or what is likely to have happened from the causes that he has had to explain why the failure occurred. Now he has to validate these hypotheses, and he has to test the hypotheses by physical testing as well as theoretical analysis. Now here you have two important formal theoretical tests for validation. That means for every cause that you have, you must be able to prove all these three. You have what is known as a counterfactual test, a causal sufficiency test, and a falsifiability test. Again, this becomes theoretical. I'm therefore skipping it. Although I've got the slides here, I'm not going to show it. We'll just skip that, just see the names. One is the counterfactual test, one is the causal sufficiency test, and one is falsifiability. Now, in the formal test for validation, an analysis or hypothesis is correct and proven only when both the CFT and the sufficiency tests have been satisfied. And every cause must both be necessary and sufficient, as we saw earlier, and no cause must be left unaddressed. All the causes, possible causes that could have led to the failure, should have been investigated, and it should have been addressed. So using CFT and CST together, it is possible to determine whether there is indeed a cause-effect relationship and whether all the causes for an effect have been identified. Again, this is quite a theoretical area. I'm not getting into that now. Then we have one other test which is called falsifiability, which is also a very interesting test. It's a term in the philosophy of science, which means that if something is false, then it can be proved or discovered by empirical means to be false. That means if it is false, if something is false, it can be proved to be false. So this is a very important test to ensure that the root cause that you have got with you, in addition to satisfying the CFT and CST, you should also be able to ensure that it is not false or it can be proved to be false. It just means everything in our reasoning must be testable and false assumptions can be proved to be false. And this is a very powerful concept for deductive analysis. So this basically brings us to the end of the testing and validation part of it. We now go to the forensic civil engineer as an expert, which is part 2. Now, almost all failures will invariably result in expenses for repair or replacement, or for compensating in the case of loss of life. If there is injury or loss of life, then can be very heavy claims for compensation. Somebody is responsible and somebody must pay. This becomes the basic tenet for any legal action that is to be taken. And so the aggrieved party goes to court to get justice and compensation. So you have the court of law, and in the courts of law, there are basically two types of law. One is called the civil law and one is called the criminal law. We'll see very quickly what the difference is. The principal difference between the two is the standard of proof required. That means the rigor of the proof that has to be submitted, and the nature of the verdict given by the court. Let us see what they mean. Building failures are almost always tried under civil law because there is generally no criminal intent, except perhaps in the case of arson, terrorism, and the like. Other than that, generally when a failure occurs, it is not because of a deliberate intent to cause the failure or cause a loss of life. So it's always an accident of some kind which has occurred for all the many reasons that you've seen earlier. And civil law deals with individuals, organizations, and within families, family law, for example. So here, the burden of proof, who is to prove? So the plaintiff, the accuser, and then initially it is the plaintiff, the person who says that he has caused a certain damage for us. And then based on the complaint that has been given, it falls on the defendant, the person who is the accused, to protect himself. Now here what happens is that they have to, again, in civil law, these two people have to argue with each other, and you have to show that who is the better arguer out here. So expert witness is the acceptability of evidence. We'll not talk about Daubert challenge. Again, that's a legal issue. I'll not talk about that now. Now here, the preponderance of evidence and the balance of probabilities is to show that the evidence provided is most likely to be correct and therefore acceptable. And it results in compensation or reparation for loss to be paid by the losing party. There is no incarceration, that is jail time, or execution of the loser. So it becomes primarily a monetary system where the judge, in the case of India, it's only a judge. In the case of Western systems, there will be a jury. They will evaluate the evidence that has been given and come to a conclusion of who is likely to be the more reasonable and correct in the arguments that have been presented, and give the judgment accordingly. And they also fix the amount of reparation or money that is payable to the party that has won. So, but here there is no jail time and there is no certainly no execution of the loser. Now, in the case of criminal law, it deals with. I'm sorry. Here one more thing is that either party can appeal the verdict, which is what you see in all the courts that we have. That the moment the district court gives a district judge gives a thing, it goes to the what you call the high court, and then the high court to the Supreme Court, and so on and so forth. So the appeal, both of them can appeal. Now, criminal law, on the other hand, deals with crimes against the state or government under statutory and common law. Now, here, the burden of proof lies always with the state government, and it must be beyond a reasonable doubt. Now, here the famous thing that every witness, I mean, every defendant is innocent until proven guilty. That a maxim comes into play here, and the prosecution must always be able to present evidence that shows beyond a reasonable doubt that what he is submitting is correct. So this beyond a reasonable doubt got great prominence during in the Perry Mason books that were a big rage in the early 60s and 70s. If found guilty, the defendant may be fined, jailed, or sometimes even executed. So criminal law does end up in jail or jail and fines, or in the worst case, it can be executed, as you see in the death sentences that are given. But here, only the defendant can appeal, the prosecution cannot. So if the prosecution loses the case, he loses the case and the case is closed. So the court and judge or jury hears all the arguments of all the parties, weighs the evidence, determines who is guilty, what the punishment should be, and what is the reparation or compensation payable, by whom, to whom. An important duty of the forensic civil engineer is called upon to do is to appear as a court expert witness in a court of law. In fact, Dr. Krishnamurthy can talk a great deal at length on expert witness, as he has been an expert witness himself in several court cases. An expert witness is a person who is a specialist in a subject who may present his or her expert opinion without having been a witness to any occurrence to the lawsuit or criminal case. That means he should not be biased. He cannot be a party of any of the people involved in a particular case, who can provide evidence acceptable to the court of his or her expertise, training, and special knowledge. He should be able to prove that he is competent and he is capable of giving the evidence that is necessary, and who is recognized and qualified by the court. In fact, this is again a very, very legal issue, qualified by the court, where you saw the one earlier where you had the term Daubert challenge. That is where the qualification of the expert can be called into question, and he has to prove himself. He may be the most eminent engineer in the world, but ultimately the court has to certify that he is qualified to give evidence in that court in that case. Even though he may have given evidence in a number of other cases and accepted by a number of other courts, that does not necessarily make him qualified by a given court for a given case in that court. So he is recognized and qualified as being competent to provide expert impartial opinion as required and instructed by the court. That means he must be independent, he must be competent, and he must act according to the directions of the court. Now, this is what an expert witness is supposed to do. Expert witness is one who has made the subject upon which he speaks a matter of particular study, practice, or observation, and must have a special knowledge of the subject. In order to bring material evidence, in order to bring evidence of witness as that of an expert, it has to be shown that he has made a special study of the subject or acquired a special experience therein, or in other words, he is skilled and has adequate knowledge of the subject. An expert is not a witness of fact. He should not be involved as a witness of what happened. He is only a witness of the evidence that he has collected, and his evidence is of an advisory nature. The duty of an expert witness is to furnish the judge with the necessary scientific criteria. He is an assistant to the judge. Remember, he is an assistant to the judge. He assists the judge in coming to a decision about the culpability or otherwise of the people concerned. The duty of an expert witness is to furnish the judge with the necessary scientific criteria for testing the accuracy of the conclusions so as to enable the judge to form his own independent judgment by the application of these criteria to the facts proved by the evidence of the case. That means he has to help the judge come to a conclusion based on the evidence that has been provided, by justifying the evidence that has been provided, so that the judge can make a clear and independent judgment on the basis of the facts that have been provided. The scientific opinion, the scientific opinions, scientific evidence, if intelligible, convincing, and tested, becomes a factor and often an important factor for consideration along with other evidence of the case. The credibility of such a witness depends on the reasons stated in support of his conclusions and the data and materials furnished on the basis form the basis of his conclusions. So he must be an expert in his subject, and he must be able to prove that what he is saying is true to the satisfaction of the judge and the jury and also of the opposing side. So he must be able to prove his point and be able to stand and defend himself. The expert witness will have to prepare detailed documentation, present the findings of his investigation in simple language understandable to the layperson, be prepared for cross-examination, which is a very, very difficult thing to do, be able to defend his position and convince the court, and he will not determine who is to blame. He only presents the facts as he has been able to deduce. The judge decides who is to blame and how he should pay. The expert advisor is normally appointed by a party to assist in the formulation of a preparation of party's claim. He is not an expert witness, he is an expert advisor. So, for example, if the defending party wants to get expert opinion, they appoint an expert advisor, but the expert witness is appointed only by the court. And he does not have an overriding duty to the court, but only to the party instructing him. So the earlier you saw the ethical dilemma that you had of the expert witness about the kind of temptations and the kind of ethical problems that he might face. So in the ideal case, an expert witness will be independent, he will be free, and he should not be susceptible to monetary or other pressures. Whereas the expert advisor only acts according to the brief that the party hiring him has given him. So he does not have any duty to the court. He is only an advisor. The expert witness must be able to simplify complex ideas and concepts into much simpler language and examples so that they are easily understood by any non-technical person like the judge, jury, and the public. If a witness starts giving explanations like this, nobody will understand it. But if, on the other hand, he just produces a few simple slides or a few simple models or a few simple animations, then he becomes much more effective in being able to communicate what he is intending to say. He should be a good storyteller, use simple graphics, physical models, computer animations, etc. to get his point across without losing the technical basis and strengths of his argument. That is where his expertise really comes into play. Every failure teaches us some very important lessons on why and how it happened, and sometimes gives us seminal insights into unexpected properties of materials and structural behavior and human behavior. These lessons have often led to overturning established theories and dogma, and theories being revised and building laws being revised. In fact, the development of structural engineering has been greatly enhanced and improved because of the study of failures of several major structures and buildings, which have subsequently found their way into the way analyses have been done, into the way building laws have been formulated, and in the way construction practices are being carried out. So failures actually have a tremendous impact on how designs are done and how construction is completed, so that we can live and work in a safer environment. In fact, this particular thing, it can be the subject of a series of seminars on how building failures have helped change building laws or understanding of building materials and behavior of structures and so on. In fact, the separate series of seminars on just failures and what they have taught us can be a very useful series that can be thought of. The great utility of forensic engineering is identifying potential causes of failures and devising systems, methods, and details to prevent failure in the future. This is of particular importance in the fields of risk analysis, reliability engineering, and resilience engineering, all three of which are very, very major subjects in their own right. Okay, we come to the end of the program. We now have a very quick thing of forensic civil engineering in archaeology, and where forensic civil engineering techniques are used to uncover the secrets of how the ancient structures were built, and not really so much about how they failed. I mean, of course, how they failed, but more importantly, how they're standing even after thousands of years. So, how they have stood intact for centuries in spite of the ravages of nature is a mystery, and forensic civil engineering can help you to find out why all these structures, which are several thousand years old, are still standing in spite of earthquakes, in spite of typhoons, in spite of storms, in spite of all the vagaries of nature that we have. And here you have, for example, so many cases that we have seen in the recent past, and they have also found out to be, I mean, also important to find out how they have failed and how they can be repaired and restored. This is a very big subject by itself, and we have had, in fact, quite a few seminars in the last 1 year where this particular subject has been talked about and explained. Now I come towards the end of the program. Questions are often asked when I have given this talk: how do I become a forensic civil engineer? I will try to give you a very simple flow chart for this. One is, of course, path one is by gaining work experience. You have to have a minimum BTech or MTech degree in civil engineering. Then you join a good consulting firm which does forensic investigations as part of their work, and you work and gain practical experience during your work in forensic investigation techniques and practice. These are the best way right now that we have for any young engineer who wants to get to the field, to have a good degree in civil engineering, and then getting into a good consulting company and learning the job on the job. The second way, which is becoming more practical now in India also, is by getting a college degree in forensic engineering. What you see earlier, this case, was the only way you could do it till a few years ago, because there were no forensic civil engineering courses available in India. But one of the interesting things is that after the 2013 forensic conference, which I organized under the auspices of the Association of Consulting Civil Engineers, it opened the eyes of a large number of people, and I'm particularly gratified and happy that today there are at least eight institutions that offer courses in forensic civil engineering. So you can actually aspire to get a degree or a diploma in forensic civil engineering today in India over the last 8 years that this has happened. And I should mention here a particular word of thanks to my good friend, Professor Sunil Kute of the Pune Savitribai Institute of Technology in Pune, who was the first person, as far as I know, in India, who actually started an elective course in MTech in the Pune Savitribai University in Pune, by introducing an elective course in forensic civil engineering, using, of all things, the the conference proceedings of the first conference of forensic civil engineering in 2013. And he had quite a few students, but today there are at least 8 universities or institutions that offer courses in forensic civil engineering in India. So today it is possible for a young engineer to get a diploma or a degree in FCE. So you enter a college in university, or much better overseas. There are literally dozens of universities offering specialized courses of all kinds in forensic civil engineering overseas, if you can't get it in India, and get a bachelor's or master's degree in FCE. And then, of course, go back, start working in a forensic civil engineering firm, because nothing like working in an actual uh, consulting firm will give you the kind of experience that you need, the hands-on experience, unless you sit in an office. What you learn in the college is theoretical. What you learn in a consulting firm is practical, and you need the former in order to get the latter. So work in a consulting firm and which does forensic investigation and gain practical experience. At present, there is no certification available for forensic engineers. In fact, there is no certification available for professional engineers itself. And we have been fighting for the last 25, 30 years with the government of India to allow professional engineers to be professionally certified like they do for doctors, for chartered accountants, and so on. But engineers do not have statutory protection today, and therefore the question of certification for forensic civil engineers is still a long way off. Now, here you find a series of, in fact, I must thank Professor Sunil Kute, who had produced this for the 2016 conference when I requested him to prepare a paper on forensic education in India. And I've taken it from that paper. Uh, and now, right now, Gujarat Forensic Science University in Gandhinagar near Ahmedabad gives you a full MTech civil engineering course in forensic civil engineering comprising 4 years or 2 years. And Professor Kute's son has completed that. Then Savitribai Phule University, which is what I told you, they had opened an elective course. They were the first in India to do that. Then we have got another very interesting institution called the International Forensic Sciences Institute, in the done by the government of Maharashtra, and they have several online short and long-term certificate courses in forensic civil engineering, which range from something like 25,000 to 75,000 rupees for a 2 week to, I think, 4 month course or something like that. You can actually Google this and you can get the entire brochure. Then you have got NIT Tiruchirappalli, Shastra University, University of Calicut, SRM University, and Northern Engineering College. These are the eight universities that I could find as of date where you can get forensic engineering diploma or degree. This was not available even 5 years ago. It has happened in the last few years only. Okay, now after that, after you finish that, you also never stop being a student. Continue to be a student all your life. Gain and enlarge your knowledge and experience by taking online courses, attending conferences, seminars, reading books and periodicals. Many are available free. And then, of course, joining professional associations and societies. I can't tell you how important this is, because you get exposed to so many new ideas, and they conduct so many webinars and conferences and programs that enlarge your knowledge and experience. So we have the Association of Consulting Civil Engineers, Indian Association of Structural Engineers, Indian Geotechnical Society, Institute of Bridge Engineers, International Association of Bridge and Structural Engineers, and so on. Of course, and the Institution of Engineers. All of them are professional institutions, and I would encourage all the young students, once they pass out of college, to join one of these institutions or more than one institution. I'm a member of almost all of them, except IGS. And it helps broaden your knowledge and broaden your vision and broaden your understanding. And then attend programs conducted by them. Now here you find these are the three conferences. The next conference is what I'm planning in 2021. I'm sorry, this is a brochure that was produced for 2020, but that had to be abandoned because of the COVID pandemic. But we are hoping to have this again through the ACCI in 2021, for God willing. Then we have these are two websites that one is a Facebook page which I have created, Forensic Civil Engineering. I'll encourage all of you to join it. You get a large number of very interesting posts out there. And then there's also a WhatsApp unit that I've started for forensic civil engineering, where you get details of not only building failures, but also notices of conferences and webinars on forensic civil engineering. Now, both of these are, you can certainly join them. There's no problem. Then we have, what is very interesting is that a large number of books on forensic civil engineering is available free on the internet. It's available free on the internet for you to download. And all of these are available free. And in fact, if you go to the internet and search for free books or free PDF cases, free PDF files for forensics, for failure analysis or forensic engineering, you will come across these. And if you don't get it, you can write to me. I'll be able to send you the links or even the books themselves. Okay. Then we have professional websites. This is, for example, the Institution of Structural Engineers, London. Then we have the Building Failures Forum, the Engineering News Record, the National Disaster and Failure Studies, NIST. So there are a number of places where plenty of resources are available overseas, where you can gain and enlarge your knowledge. And then, of course, these are two articles which I have written. One is for Built Expressions in 2012, and now recently, in fact, Nebu Abraham has been very kind to give this as a free download. You can go to constructionphilosophy.com and download this. There's an article which I've again given, which is basically a much more condensed article of this same lecture. Okay, now having got a degree and having worked, what are the job prospects? This is another question that I'm very often asked. A large number of structural failures and collapses are taking place in the country, and there is a great an imperative need to do complete forensic investigation to find out what went wrong and why, so that important lessons can be learned and applied to future projects so that such failures can be avoided. So there is no doubt a great need for trained and experienced forensic civil engineers in the country, and a large number of forensic investigations are being conducted in India today. But there is a very strong culture in India to discourage forensic investigations, principally because of liability and reputation issues. And even if a forensic investigation is done, the results are never allowed to be made public. How many times have you heard where a failure has occurred, a building has collapsed? For example, the main bridge, bridge failure that occurred in Calcutta. It so many investigations have been authorized, and probes have been authorized. But when have you ever heard of any report being made public and any report being made available to the public? Nothing. They are all suppressed. Everything is after the initial excitement of maybe 2 or 3 weeks, and after the local municipal corporation or the local authorities put out statements, and the local minister's politics comes into the picture, they all say, okay, so many people have been suspended, this, that, and so on. Have you ever heard of anybody being jailed? Have you ever heard of what has happened subsequently? Everything is hushed up, everything is kept quiet. And this is unfortunately a culture in our country, whereas overseas, they are required by law in order to publish the results of the investigations, and there is a public inquiry that is done. And therefore, what happens is nobody can escape, and the law is very strict, and the law is very strong, and it is enforced. Unfortunately, we have all the laws in the world, but enforcement is almost non-existent, and that is the problem why there is a very strong culture to discourage forensic investigations. And therefore, there is an urgent and imperative need to change this mindset in both the people and the public and private sectors to allow forensic investigations to be made and also the results to be made public. And it's also necessary to statutorily recognize forensic civil engineering and forensic civil engineers. So that essentially brings me to the end of the program. What is it I've told you till now? Forensic engineering techniques enable to understand how high structures fail, how to design better structures, and also to understand the secrets of ancient and historical monuments. It is today a very important and recognized discipline in civil engineering worldwide, including within its scope a vast range of subjects. In India also, it's happy to say that this subject is now gaining more and more acceptance and more publicity. And thanks to webinars like this, more and more people are coming to know about the subject, which is a very happy development. Universities offer specialized courses in the subject overseas, and separate certifications are available. In the US, for example, there are at least 5 national level institutions and organizations devoted to forensic engineering, including the American Society of Civil Engineers, which has a separate forensic engineering division. Numerous conferences and seminars are actually held worldwide, and if you get a chance to attend them, please do, because each conference and each seminar, each speaker brings something new to the table, and it's a very learning experience for everybody. In India too, FCE is being recognized increasingly in academia and offered as an undergraduate, postgraduate course or a diploma course in several colleges, as you have just seen. Okay, so what is it I have left out? Failure cases. There, perhaps, as I said earlier, we can have a whole series of separate lectures and lessons learned from failures and greater understanding of structural behavior and design, regulatory requirements to prevent failure, code provisions and revision of failure and revision of codes, safety and reliability issues in FCE, repair, restoration, retrofitting, and rehabilitation. Lot of the webinars and seminars are being conducted on this, especially heritage structures. That is something very interesting to learn about how they rehabilitate or restore old structures to more or less a new condition. And then software for FCE and many more other related subjects. As I said, the subject is extremely vast and extremely complex, and you can have a 1 month program on this and still not complete all the subjects. Just to give you an example, here is just a selection of the various different subjects that can come under the overall envelope of forensic civil engineering. So that brings me to the last slide, and thank you very much. I am now open to questions. And if you have any questions or any, if you would like to contact me, I've given you my email address as well as my telephone number, and you're most free to contact me at any time. Thank you very much indeed. And thank you once again, Nebu Abraham and Mr. Joseph, for having brought me into this program. Thank you very much. And thank you all for a patient listening.
Sir, can you explain a case study about a simple case study?
Can we do it another time?
Okay, sorry. It's okay. Sir, anyway, we are very grateful to you, sir, because for just like forensic medicine, forensic engineering is also a very complex subject, and very well experienced engineer can only practice this subject. And we understood that a technocrat like you only can do this thing, and a lot of experience in various fields in the construction sector can also practice and this type of specialized subjects. And we are very grateful to you for sharing your valuable time with us. And this is a very vast subject, and within this 1 hour, I think we cannot explain all these things in detail. And I also expect next time you can give a more case study about this.
Certainly.
On behalf of BA Coaching Center, I extend my sincere thanks to Rao sir and Natarajan Krishnawar sir. Thank you so much.
Thank you very much indeed. Thank you.
Thank you so much.
Out Nebu, please.
That was indeed a great session. What more I can say? And we are very, very, very much blessed with the presence of engineer Natarajan Krishnamurthy as well. Thank you so much, Natarajan sir, for being here. Being so kind to be here at this point of time. And thank you so much, Rao sir, for spending your valuable time to enlighten us with such a brilliant topic. Indeed, forensic engineering has to be much popularized here because the failures are never been celebrated here. The failures also have to be celebrated, since that should be the eye opener. And when you have an area of this kind, most probably we can avoid a lot of disasters. When you know the reasons and the possibilities of failure, you have all the opportunity to control it, and you have a more safer environment in the field of construction when you deal with such failures. So, thank you again, Engineer BSU Rao sir, and also Natarajan sir for being here. And thank you.
Just one word.
Yeah,
Yes.
please.
Just one word. I have, Mr. Rao has praised me so much, but let me admit that today I learned a couple of things. It's a very big subject and he has covered it beautifully. So I congratulate you for organizing it and him for presenting it. Thank you and God bless.
Thank you, sir. That means a lot to me. Thank you very much.
Thank you so much, Krishnamurthy sir, for that nice words. On behalf of BI Coaching, once again, let me thank you. And for every participants of this occasion, actually, there is one issue. The latest issue of Construction Philosophy magazine is on forensic civil engineering, and we have a large, article written by Engineer BSC Rao, and it is available for free download. Everybody, I have shared the downloading link also. Please take this opportunity to download and read the article so that you can be more enlightened, and you can read a lot about the need of forensic civil engineering. Thank you so much, Jolly Wagi sir, for conducting such a wonderful event, and thanks to everybody for attending this session. Till we catch up for the next session, goodbye to you all. Good night.
Thank you, Rao sir, Krishnamurthy sir, and Nebu. Good
Thank
night.
you. Thank you all. Good night.
Good night.